All right, so number 5 is a lot more like what we were doing on day 3 notes, graphing. But we're given the information in a little different format. The other day it was just kind of all listed out, kind of like our class starter today. So let's look at how to approach this one. It tells us that f is continuous from -1 to 7, so we've got our graph ready to go from -1 to 7. F of -1 is 3, so it's kind of like our starting point at -1, 3. And f of 7 equals -1. So it's only giving us 2 points, the beginning and the ending. The rest we're going to have to figure out on our own, and we're going to use this table to help us. Nice thing is when it's set up like this in the table, it's almost like our number line is done for us. You don't necessarily even have to write out a number line, but I'm kind of used to it, so I'm going to do it, and I think a lot of you may like it this way better. But this table is telling us, first, the derivative. Right? The derivative is 0 at x equals 1. Derivative is undefined at x equals 2. And the derivative is undefined at x equals 4. Those are our critical values. 1, 2, and 4. Right? It's undefined at these two values and 0 at this one. Then it tells us when it's positive and negative, when the first derivative is positive and negative. So it's negative, then positive, positive, then negative. So that information gives us when it's increasing and decreasing, when our original function is increasing and decreasing, and when it changes certain ways, we get our minimums and maximums. So at x equals 1, what are we getting? Changes from negative to positive, what kind of a point do we get? We're going to have a minimum on f. At 2, it's not changing. Right? It's positive, then positive. First derivative is not changing, so there's no minimum or maximum. At 4, the derivative changes from positive to negative, so f of x is going to have a maximum. Now, we have to pay attention to the fact that these derivatives are undefined. Right? So when we have an undefined derivative, one of two things is most likely going to happen. We're either going to have a vertical tangent line or a sharp turn. So there's a way to kind of tell. If we have a max or a min at a point where the derivative is undefined, that is going to be a sharp turn. Right? And we'll see that in a little bit. If we don't have a max or a min at a point where the derivative is undefined, that's going to be a vertical tangent line. All right, so we'll see that in a little bit when we get to the graphing part. Now, we also want to look at our second derivative. So our second derivative, same values on the number line, 1, 2, and 4. Our second derivative is 0 at 1, undefined at 2, and 0 at 4. And we can see the signs there. We have positive, positive, negative, and positive. So this is telling us when f of x is concave up or concave down, and it also allows us to find the inflection points. So where do we have inflection points? 2 and 4. Right? It only happens when the second derivative changes from positive to negative or negative to positive. All right, positive, negative, or negative to positive. Here it's not changing, so we don't have an inflection point. Well, now we have to go ahead and graph these points. We need to have our minimum, maximum, and our two inflection points plotted on this graph. So we're going to start with our min and our max. We have a minimum at x equals 1, but there's not a point plotted there, so we have to decide where that goes. And really, we can go anywhere as long as it's lower than this point. Right? As long as it's lower than this point, because it's going to have to go down, it's decreasing, right? The derivative is negative, so f is decreasing, so it has to be lower than this point. It doesn't necessarily have to be lower than this point over here. I mean, it could be right here if we wanted it to be. So it doesn't really matter as long as it's lower than this point. I'm just going to go ahead and put it down here. Again, we could put it at 1, 2, 0, any of these points. I'm just looking for the basic shape and making sure that you have a min, a max, and inflection points at the right x values. Then we have a maximum at x equals 4. Well, that point has to be higher than this one and this one, right? It has to be somewhere higher than those 2 points. So at x equals 4, again, I can put it anywhere as long as it's higher than that. So I'm just going to put it up here. Again, it's up to you. You can move it at a different point if you wanted to. Next, I'm going to go ahead and plot our inflection points. So we had inflection points at 2 and 4. Well, 4 is already plotted, right? This max is also an inflection point, so we don't have to do another point for that. But at x equals 2, there's another inflection point. So between this minimum and maximum, right? This is going to be a min, this is a max. So our inflection point when x is 2 can't go lower than the min, can't go higher than the max, so we're just going to put it somewhere in between. Again, it doesn't matter where you put it in between, as long as it's in between those. And now we can use the concavity to connect the dots. Right? So down here, concave up until we get to 0. Sorry, until we get to 1. So from here to 1, it's going to be concave up. So kind of like that half of a U. Then from 1 to 2, it's going to be concave up again. So from here to here, concave up, half of a U. Then from 2 to 4, it's concave down. So from here to here, concave down. And then from 4 to 7, it's going to be concave up. So from here to here, concave up. We're doing half of a side, or like half of a U. Remember, careful, don't go below that, like I just did there. Right, because that would create a minimum. Remember, we talked about this. We should have a sharp turn at this maximum, and we do, because of that concavity. And a vertical tangent at this point, which we do because of that inflection point and change in concavity.